Thanks, Adel. You're doing fantastic job. I think we have got many interesting sessions today, and everything is going on well, right?
Yes.
All right. So I'm going to share my complete screen, and let me know once you see my screen. Is it visible?
It's now visible. Yep.
All right. So the topic here is a priori unification pattern for efficient machine learning. So we will know what does this mean. Though it is sounding a little bit complex and difficult, it's a very easy design pattern that I'm going to discuss today with all of you. So I will start by giving a very brief introduction about me. I'm a technology evangelist, one who likes technology and more oftenly on the open source, a lot of open source technologies. Because I see that in the current world, you can do wonders by using existing open sources, combining them, integrating them efficiently, and making results out of it. My experience over 20 years in trade and logistics, healthcare, financial, transportation, business intelligence, big data, etc., and well versed with distributed computing applications. And I have given some of the references which I will be converting into PDF and sharing to all of you so that you can just click on the links and read some of the machine learning things that I have done on my past experience. And on the left hand side, you can see my LinkedIn profile. Please connect with me or shoot an email whenever you have any questions or you need more clarifications, you need more consultancy, etc. And as a whole, this machine learning world, I would like to call it as architecting the unknown. Why? There is a big difference between science and computer science, right? Science is moving from unknown to known. We don't know about solar system centuries back, right? We don't know about what moon is all about, what is the shape of earth. Everything was unknown. Science helped us to move from unknown to known, right? What about machine learning? What about computer science in general? We move from known to unknown. That's the difference. Because we got some data, and that data is raw. We don't know how to make sense of that particular data. As we write our algorithms, as we combine them, compose them effectively, combining data from multiple sources, we start getting the value out of that data so that we are figuring out what was unknown in that data. So I would always tend to call my field as I'm always architecting the unknown. When I start with something, I don't know, but I move in order to find out what is in it, right? All right. So, very simple agenda. What we are going to talk about is we'll start with a simple example. Okay. What is this a priori unification? Then we look at the problem statement. We look at the solution. We look at the advantages that we want from this particular architecture. And finally, we will go for a demo so that you get the complete picture, right? And feel free to ask any questions during the question and answer session or anytime, shoot an email as I mentioned to you earlier. All right. So it's evening, right? Anyway, I'm broadcasting from this sunny state, Florida, in United States. So here it is evening. So let us take an example. We want to make nice broccoli chicken, right? And assume that broccoli and chicken are available to you. Small data, it's available. Okay, let's assume that. But you don't have soy sauce and salt. Let's assume that soy sauce and salt are the external data, right? So we are going to cook, we are going to make broccoli chicken, right? And call that as our ML or AI application. We got data. What are our data? Broccoli, chicken, soy sauce, salt. Broccoli and chicken are available, but soy sauce and salt we need to bring. The cook is ready, and we are going to start cooking. And let's see a good approach, right? You want to buy soybeans. You want to bring in raw salt. And you have chicken, you have broccoli. But please look at that diagram. I don't have soy sauce. I have soybeans. I don't have refined salt, but I have only raw salt. So this guy is doing little bit tedious work, even though it is a nice approach. What is that he or she is doing? Is bringing the soybeans and creating the entire process of converting that soybeans into soy sauce, the raw salt into the refined salt, iodized salt, and then he or she is going to combine the chicken and broccoli and going to cook it. You'll ask, is it good? Well, this cook is a special kind of person. He wants everything in his house. The complete factory which converts soybeans to soy sauce. The complete factory to convert the raw salt into the refined salt, right? Whatever complex process you saw in the previous slide, he or she is building in the home and then creating this particular dish. So let's think about this particular process. Is there any disadvantage? Okay, first thing, how much space you need to build this factory? Soybeans to soy sauce and raw salt to refined salt. How many areas you want? In our computer world, how many machines you want? And are you going to tie to a particular company? Are you going to build it monolithic? Can you do parallelization while you are doing the work? If tomorrow a new machine is coming, can I just take it out and plug it in? Difficult, right? If you agree that this particular process is okay, you are doing everything by yourself, but it is very complex, it is not nice, that's what the entire world of machine learning and data scientists are doing. What are you doing when you want to combine the data from multiple data sources? You are connecting to the database, bringing the data from Oracle, bringing the data from the other system, MySQL, bringing the data from SQL Server, and then you are doing the complete factory of soybeans to soy sauce, raw salt to refined salt within your ML application. So how can you make it better? Come on, you already know the answer. Just buy the soy sauce, just buy the refined salt from the market and just prepare the chicken in your machine learning application. What did you avoid here? You avoided that complete heavy lifting, the process of refinement of the data. If you are not using this approach, as you have seen in the previous slide, you might have created that entire factory in your application for converting your data, and then you might have used that in your application. But is that a good approach? Your ML application in data science is meant for machine learning algorithms. It is not meant for data refinement and data factory kind of things. Whenever you want to get the data from multiple systems, you must not attempt to do that within your ML application, but you should consider it separately. If there are people in this audience who are familiar with web application development, what is meant by model view controller architecture in the web development? What did you do? Rather than writing the entire code in an HTML or a JSP code or a ASP code, what did you do? You just created a view, which is the presentation layer. You will use React.js, AngularJS, those kind of applications. Then you will have a kind of model, which is doing the business layer. And then you are going to have the data, which is connecting to the database layer. Model, view, controller, architecture, correct? We could have written everything together, but that's not a good design pattern. In the similar way, in ML applications, if you are combining everything about data from multiple systems and you are doing those kind of things inside your ML application, it seems that it is not a good design pattern. And my experience working on different ML projects where the data is brought inside the ML application and then joining affected a lot of out-of-memory exceptions in your ML applications. Please search Spark out of memory joining the data frames. You will get more than 10 million hits in Google. The reason is if you are not prepared to manage the joining of the data very well, you are going to hit with out of memory. Why? Because assume that you are bringing 1 terabyte of data from MySQL and another terabyte of data from Oracle, and you want to join it, and the resulting data is just 10 million rows. But for joining, you are bringing the entire terabyte into your ML application, which is not good. So we should try getting the unified data. And what is the advantage? Tomorrow, if this soybeans to converting into soy sauce is a different company, I can just change it, but my ML application is not changed at all. I can do distribution because I am unifying it outside. It is fault tolerant, which means that if something is not working, I can just plug it with another and it can do an automatic failover. It's extensible. What do you mean by extensible? If suppose you want to join one more data source, you can just add that extra data source here and next data source here, and your ML application still remains mostly agnostic to what changes are happening outside. So this architecture is polyglot and flexible. And this design pattern is what I mentioned as a priori. That means we are doing a unification and combination of data prior to bringing it into your application. Looks efficient, right? So what will be the overall architecture? Always you will have your ML or AI platform or your application, your Jupyter notebooks, your R code or your Spark code, whatever it is, right? But whenever you have a situation where you want to join multiple data sources, remember that use case. I'm not talking about one data source. If it is one data source, you directly pull it. There is no efficiency here. Why? Because it is just one. When you are dealing with multiple data sources, because the world is going into big data, you might have seen a lot of presentations today talking about data science and big data, right? What is big data? Big data is talking about not one single database. Big data is talking about polyglot persistence, which means that you may have MongoDB, you may have Oracle, you may have MySQL, you may have Pinot, you may have the Hive, Hadoop, right? So there are multiple systems in the enterprise, and there may be websites from where you want to do the web scraping. You want to bring the weather data. You want to connect to the CDC website and get the COVID-related data for those analysis. Multiple data sources. And whenever you want to combine that multiple data sources, please don't bring individually all the data sources into your ML platform like the guy who was creating the soy factory and the raw salt factory, but join it before you are bringing the data into your ML AI platform. And once you bring it, you start doing your imputing, balancing, your correlation analysis, all those kind of things into your ML application. But the most important thing to note here is you are bringing the unified data, not the individual terabytes and petabytes of data into your AI platform, which may not scale. Even if you use the application framework like Wakes in Python, there is a limit to the distribution. Why? Because you are unnecessarily storing the data. All you need is the unified data from all these particular data sources. So, a priori unification means you are keeping a data virtualization layer in front of your ML AI platform. And trust me, this has produced more than 40 to 50% of efficiency in the ML AI frameworks that I daily deal with. It allows more concurrent users to run your ML AI applications and algorithms. You just assume that in an enterprise, there are 3 different departments running ML and AI code on a single platform, and all the 3 groups are bringing individual data sources. There is hardly any space for dealing with your ML AI algorithms as such. Why? Because already the platform is filled with the data. What are you going to do? There is no memory. Even if you use columnar formats, you use Parquet, ORC, advanced kind of formats, compressions, columnar data, no use. Why? Because terabytes of data are residing in the data frames. And you know very well that in Jupyter, if you are executing a data frame, that data frame will be available until you finish off that particular code, correct? So, what's a good option? We should have a data virtualization tool, right? So let me introduce one of the most powerful data virtualization tool, completely free, of course. Save millions of dollars. How? Use PrestoDB. PrestoDB is open sourced by Facebook in 2013. And please look at the left-hand side. You cannot find a commercial vendor in this industry who has been stress tested to such a big scale. Look at the companies which are using PrestoDB. You will know what is the scale in which they are working. And this particular sentence is taken from the PrestoDB site. You can see how Facebook is using PrestoDB. 300 petabyte of data warehouse, 1,000 Facebook employees, 30,000 queries. Pretty stable, completely free. It works very efficiently. Whenever you write a query, it will combine the data from multiple data sources. Please look at this right-hand side where you will see this is one data source, this is another data source, and when you run the query, it will do the virtualization and it will be distributed completely onto the platform and you get the resulting data. That resulting data you can use in your Python and your R and your Spark code. Well, it is time for a demo. So what I'm going to do is I'm going to open a new terminal window and I am going to go to my directory where I have installed the PrestoDB for this particular demo. And if you look at the PrestoDB, you will have this directory structure. Very simple. It's a matter of few seconds in order to install Presto. And please look, if you are going into the etc directory, you will see another directory called a catalog, and I have put 2 files inside this catalog. One is called excuse me, MySQL.properties, and another is called Oracle.properties. Can you imagine what are they? One is the soy factory and another is the raw salt factory, right? MySQL is the database which is connecting to MySQL, and Oracle is nothing but the connectivity to Oracle. So please look, if you want one more connector to MongoDB, you need to create one more file called MongoDB.properties. That's all. So quick, so flexible, so easy. And I'm going to start the server. Okay, so let me start. So your PrestoDB is running, and while it is starting up, I am going to start another window, right? And let's start a different color. And I'm going to go to the directory, and I'm going to start the PrestoDB client, right? So the PrestoDB client is started. Now, let us start writing the queries. And what's the query that you want? You want to get the data from, let's say, the MySQL tables, for example. So I am going to write select star from MySQL.ml.employees, which is going to give me the data related with MySQL. Fantastic. Let us write another query. Now I am going to take the data from Oracle. Did you change the window? No. Did you change any different connections? No. In the same window, you queried SQL and Oracle. Amazing, right? And now comes the magic. Select, right? And let us do a join between MySQL and Oracle in one simple query. Please look at that. I am querying Oracle and MySQL in one window. And once you run this particular query, you are getting the joined data. This is beautiful. And if it is not there, what you will do? You are going to go to your Python, and inside your Python code, let me take an example. You are going to write this particular code, right? So let us just look at this not efficient code. You will install the Oracle library. You are going to connect to Oracle. You are going to get the data related with Oracle. You are going to connect to MySQL, and you are going to get the data related with the MySQL. Remember that now you created two individual data frames like the soy factory and the raw salt factory, and now you are going to do the join, and you are getting the joined result. You are resulted only, you are concentrating only on this result. Why are you creating the two individual data frames which are too huge within your notebook itself? You should be trying in order to get only the unified data. So what are you going to do? Let us take the most efficient way of doing this particular one. And I'm going to call it as a priori pattern. Please look at that. Only one block of code. And in that block of code, I am connecting to PrestoDB by using PyHive. So PrestoDB comes up with a PyHive-based Python installation, a package, which will allow you to connect to PrestoDB, and you write your unified query from Oracle and MySQL, so that now you get the data frame which is the result of Oracle and MySQL, but that join is happening in PrestoDB now, not on your notebook. And you get the result. And that's the idea of a priori unification pattern. And don't worry if suppose you are coming up with, oh, how will I do if I am writing an R code? Don't worry at all. Because if you are writing an R code, you will use, instead of PyHive, you have R Presto. And you connect and execute exactly the same query, which is joining Oracle and the MySQL, and then you get the unified data frame rather than building the complete frame inside. How about Spark, PySpark? I'm sure there are people here who are writing in Spark, right? So let me open Spark now, right? So I'm going to go to my big data architecture, and I will go to my Spark directory. Spark, yeah, right. And let us go to bin, and let us start the Spark. And how will you start PySpark? Just type PySpark, right? And we have the latest version of Spark running, completely distributed machine learning platform, a distributed computing cluster. Spark is running. So what do you want to do now? So assume that you don't have this particular mechanism. What you could have done? You could have created a data frame, which is now your MySQL data frame. So I'm going to copy this particular code and I'm going to write it. Look at that. I'm creating a MySQL data frame, which is bad. Entire data is now coming into MySQL. And if suppose you write MySQL df.show, it is going to give me only the MySQL data. Not good. And if you want to connect to Oracle, you are going to do exactly the same thing. You need to install all the Oracle drivers, etc. And you are now going to write Oracle and then write Oracle df.show, which is going to print only the Oracle data frame, which is not good. Why are you individually creating the multiple data frames? Instead, what we can do, I am going to create a JDBC data frame, which is using a connectivity to Presto, and Presto supports JDBC. So, Presto supports JDBC, PyHive, and RPresto. You can connect from any machine learning tools for your AI ML applications. And now if suppose I am loading this particular data and I am writing JDBC df.show at this particular point, it is now giving me unified data rather than the individual data frames, and you get the result. Got it? That's what a priori unification pattern means, and PrestoDB is a great tool for quick installation and put it in front of your ML AI architecture. So these are the advantages. You can build custom connectors. It supports complete SQL standard. You can store the result if you want into a local storage. It has got connectivity to S3, Cloud, AWS, Azure, etc. You can access it from any language, and it has got Python or Spark integration, which I have demonstrated just now. You can write custom ELT, which means that if your data needs pre-processing, if your data needs removing the null values, missing values, etc., in the unification layer itself, you can perform it and get the resulting data into your Python or R or Spark applications. And finally, if you have reporting needs, you can connect it. And all that is completely free. So, what is the opposite? The not so nice approach of doing this? A posteriori composition. That is an anti-pattern in machine learning. And unfortunately, we are all doing that. So avoid that anti-pattern and use a priori unification, where you get the unified result into your ML applications. And then you proceed with that. Right? And that improves the efficiency. That helps you to make your architecture much beautiful and much scalable, resilient, and distributed. You will use your machine learning platform only for what is intended. Because a machine learning or AI platform is not for data storage and data management. It is meant for your linear regressions, your TensorFlow, your scikit-learn, right? So use your machine learning platform and AI platform for those purposes by creating an extra layer, right? And you might say, I have to manage that extra layer, but you are getting a huge advantage because your primary importance is for getting your machine learning output efficiently. right? So that's all from me, and thanks a lot for listening. If any questions or anything, please come into the question and answer session, and we will take it up from there.